Okay, today is the third day of day 4, and really it's just a combination. Day 1 we did some shrinks and stretches, and then day 2 we did some shifts, and now today day 3, we're just going to kind of mix them together, do a little bit of both. And I think just for consistency, it probably would help you to get it in fireproof form if you don't already do that. Just a quick review. Here's fireproof form for any function. This is just f of x. So, it could be a quadratic, could be a square root, could be a sine, could be any function. But you get it in this form, and the top half has to do with shifting left and right, and this is the opposite of what you would think. So, like when it's a minus k, it's actually right. When it's a plus, it's if it's a minus, it's up, and if it's a plus, it's down. Whereas here, if it's a minus, it's right. If it's a plus, it's left. So that's the one right here. It's the opposite of what you think. But the bottom half then are the stretches and the shrinks, and they are what you think. So those are not the opposites. Then you think left and right. Left side is all vertical stuff. So, up, down, and this would be vertically stretch, vertically shrink, horizontally. So this is left and right, and then this is horizontally stretch and horizontally shrink. So it just kind of splits it up into force. For me, it just keeps things easier to keep track of what's what. So first off on this one, we're just going to mix some things together here. So this equation, let's write it in fireproof form. So here's, I want the cosine by itself because I just want f of x and then whatever transformations inside with it, but I want that by itself. So the 2 needs to come over. So this would be y over 2, and then that would equal cosine and this, x plus pi over 4, and that would just be over 1. So this guy, if we're kind of looking at it here, if I want to figure out, some of the changes there. Here there is a vertical stretch of 2, so there's a vertical stretch of 2. This is a 1, so nothing happens there. Here's a phase shift, so that's going to go left. Left pi over 4. Okay, so if I'm looking to answer these questions, it might be easier to graph it first and then answer these questions. A few of them you can answer right now. Like I can see the phase shift on this one is a negative pi over 4. Vertical shift, there was none. There's no number here, so we just put none. The amplitude, because there was a vertical stretch of 2, the amplitude is going to be 2 in both directions. If I look at the period here, there was no number in here, no number inside there with it that would affect, this right here also does that. So the period is going to be normal. Normal cosine period is 2 pi. Okay, and since I didn't move up or down, I didn't shift it, there's no vertical shift, and the amplitude is 2, that means my midline is a 0, and it's going to get up to 2 and down to negative 2. And, the domain, since it's a cosine, sine, those are going to be everything. So the domain is from negative infinity to infinity, and then the range is going to bounce back and forth between these two. So from negative 2 up to positive 2. Okay, so if I want to graph this guy, again, I always try to think of where is normal cosine. So normal cosine, and since I'm going to have to do an amplitude of 2, I'm going to make this 1 and that 2. And negative 1, negative 2, just so I can fit it on here. So normal cosine would start here, and it would come down. I'm just going to put some points in, that way I can shift them the way I need to. Okay, so those dots would be normal cosine. Now I'm going to do some shifting. So first off, the zeros, they will move. They'll move pi over 4 to the left. And if you notice, each one of these is pi over 4. So every dot is going to move left first off. And I'll just do the zeros first because they're not affected by the amplitude. So I'll just do the zeros first. So now this is here. I'll just draw a line so I can remember which one's which. So these are my zeros. And then the peaks and the valleys here, so the mins and maxes, they're going to actually double in height or in depth, and then they're going to move pi over 4 to the left. So this one's going to go from 1 to 2, and then pi over 4 to the left. And then this one's going to double and then go over This one's going to double and then go over. I might make these a little bit darker so maybe they'll stand out to me so I don't mess this up whenever I go to actually graph them all. Double over to the left. And this one's going to double and over to the left. So those kind of darker ones are the ones I want there. So it's looks something like this. And those aren't perfect. That should come out more this way. But yeah, so that's kind of the graph right there. So just kind of throwing everything together. Yeah, so let's keep going with this. So we got 2 sine x minus pi plus 1. First off, I love it if it was just sine of, and then whether it's parentheses on the right side. So that means I need to bring the 1 over and the 2 over. So I'm going to subtract the 1 over, so it'll be y minus 1, and then I'm going to divide that 2 over, and that would equal sine of x. Whoops. Yeah, there was a lot. I didn't like the way I wrote that, so I'm going to go use some white out. So sine of x minus pi over 1. Again, so if I'm kind of looking at it this way, I've got vertically, I'm going up 1. So vertical shift, I can say up 1. And that's the baseline. So the baseline was here. It's going to go up. Whatever I decide 1 unit is, it's going to go up. Let's see, and then it's the amplitude is going to change. It's going to double because I got this vertical stretch. So that's going to be a 2. Let's see, the phase shift here, that's right. So I'm going to go right pi. And now the period, again, no number down here. That number didn't change anything. So, and we actually I should be putting this over 1 because it's all of it like that. I guess I'd kind of get ahead of myself on those things. So it should be sine or cosine of all this over 1, and this is sine of over 1. So the period doesn't change because that's a 1 on the bottom there. So no horizontal stretch or shrink, so that's 2 pi. And then think if amplitude of 2, I can make this so 1, 2, 3, 4, -1, -2. Probably don't need to go much further than that. So my baseline now is going to be right here. It's my old zeros. We're going to be on this line now because everything went up 1 unit. So that includes the peaks and valleys, and the zeros will go up also. So if my baseline is at 1 and my amplitude is 2, that means I'm going to get up to 3 and get down to -1. Because it's a sine function, the domain will be from -infinity to infinity. The range, again, will be from the minimum to the maximum. -1 up to 3. Those guys are both included. So I said, always helps me do the normal sine, okay? And if you want to, I might do the normal sine with the vertical shift up 1 to start out with. So it would have gone through 0. So it would have gone up through 0. Now it's going to be going up through 1. And then it would go up 1. It looked kind of something like this. And this is just normal sine. Just put out a line so I can remember this is not the one I want to, not my final answer. Okay, so that's with the vertical shift in. Now, I need to change the amplitude. So the amplitudes are all going to double. So instead of going up 1, I'm going to go up 2, and then I'm going to move to the right pi units. Okay, so this is going to, or this is a 0, it's going to go over pi units. So yeah, I'll take care of the zeros first. So I'm going to go over pi units. So this up will now be here. I'm just going to put a little dash line up so I know that that's an up. This down will be here now. This up will be here now. And then that was a down. Now it'll go to here. And then the amplitude is 2. So instead of going up to 1, it's going to go up to 2. Well, this one's actually going down now. So this is going down. Instead of going on 1 unit, it's going to go down 2 units. Then back up through, and then up 2 units to 3. It's going to come back through here. Yeah, period. Okay, yeah, and I think we connect those guys. So this one's a solid 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. Okay, so it got doubled in height and then shifted over pi units, and that's why all the ups became downs. We went down through instead of up through. So, if that got a little confusing, that's why. The backside now. Let's see. Now this is in fireproof form. Notice because cosine's by itself over here. So now we want to write it in standard form, just for practice. So I would want to double this. So I'm going to multiply the 2 over. So that'd be 2 cosine x minus pi over 2, and then subtract the 1 over minus 1. But I'm still going to use this to do all my answering here. Okay. So I see on this one there is a let's see, the plus 1. That means I'm going to go down 1 unit, so vertical shift down 1. I got an amplitude of 2, and then I'm going to do a phase shift of right. I can't even spell today, good grief. Pi over 2. And then, again, since this is not all over anything, the period is going to stay 2 pi. And so if I go down 1 unit, that's my new baseline. I'm going to do 1, negative 1, negative 2, negative 3. So now here's my new baseline, and cosine would normally be up 1 unit from that. It looks something like this. Okay, but now we're going to shift it. So every point, every zero is going to go pi over 2 to the right. So maybe I'll just shift those right now. So here are my zeros. Pi over 2 would be here. So here's a new 0. Here's a new 0. Here's a new 0. And there's a new 0. These heights will be double their height, but they'll also go over pi over 2. So they're going to be twice as tall and over. So this one's going to be twice as tall and over. Whoops, this one. And this one will be twice as tall and over. This one will be twice as tall and over. So it looks something like that. You can continue this on then, right there. So min, max, let's see, the maximum or minimum, -3, maximum 1, domain, negative infinity to infinity, the range, -3 to 1. Okay. Next guy, just for a little bit of help here, if I'm getting this into fireproof form, this is the first one that has a 2 here. Okay, so that's going to be changing the period. That's going to be a horizontal stretch or shrink, depending on what ends up happening here. But I want to first off get this by itself. So I want to work on that first. So I'm going to have y plus 4 divided by 3. And that's going to equal sine. And I want this to be just x. Okay? I want that to just be x minus something. So I might have to divide. Now, in order to get, in order that to be a 1, it's kind of a weird way of thinking here. So I have 2x minus pi. And we know that when you divide something by a half, if I had something divided by a half, that's the same thing as multiplying by 2 over 1. I'll just call that x right now. If I had x divided by a half, that's the same thing as multiplying by 2. Okay, so I cover this up and I can multiply by 2. Go the opposite direction. Multiplying by 2 is the same thing as dividing by a half. So I could actually divide both of these by a half. So divide by a half, divide by a half. So now it'd be x minus, and in order to get that to be over a half, I got to put this over 2 divided by a half. And if you flip this guy over, if I divide by half and I multiply by 2, if I do that, I come back to the original. Okay, so anytime you're dividing both of them by 2, well, take half of this, that's what this is, and then put 1/2 on bottom. So you actually took half of each one, and that's set on bottom. So, for instance, if it was 3x plus pi, I would take 1/3 of both of those, so it would be x plus pi over 3, but then I'd put a 1/3 on bottom. These are equivalent. That's just a totally different situation. So here, I'm going to divide them both by a half, so that'd be x and then pi over 2, but then put the 1/2 on bottom. Okay, because when you do this, when you multiply by 2 over 1 by the reciprocal, you get the original thing back. So these two are equivalent statements. So x minus pi over 2 over a half. And all that does is, when this is a half, now this is horizontally, it is what it is. So that is a shrink now. Okay, so a 1/2 means a period is basically 1/2 of what it was before, which means if it was 2 pi, it's now pi. If you remember from the first day, we said whatever this number is, that's your b. If you took 2 pi divided by 2, that's your new period. So those both those things are saying that the period is pi now. Okay, so we got pi, we got an amplitude of 3, we got a phase shift here of pi over 2, so that's to the right. And we got a vertical shift over here of -4, so down 4. There's a lot of stuff going on here. So first off, I'm going to change these just so I can fit this on here, because if I make this 1, 2, 3, 4, there's going to be my baseline, and that's too low. So I'm going to make them -2, -4, -6, go up to 2, go negative, or down to -8, kind of make that. So my baseline now is at -4, or my midline. I keep saying baseline in this video. I need to say midline. If I haven't said that, I mean to say midline. And so my, let's see here. So normal sine, if all it was that vertical shift, normal sine would come up through it. It'd go up to 1, go up to 1 here. I'm going to white out that so I don't mess myself up. And then it would come down here. So there's what normal sine would be. So if I just get my idea of what I'm changing, now I'm going to have an amplitude of 3, and I'm going to move it pi over 2 to the right, that first one. So let's do that. Well, I guess the first one's a 0, so let's go pi over 2 to the right. So now this is over here. And then from there, the next point, this height is going to be 3 times as tall, and then pi over 2 to the right. So I'm going to go 3 times as tall. It was at 1, now it's 1, 2, 3. I'm going to go pi over 2 to the right. But not only is there that phase shift, but now it's going to have to repeat itself more often. So I can't, this was originally a pi over 2 from the 0 to the peak. Well, it's going to be half that now. So now this peak is going to be here. Okay, because I need to do a full cycle of pi later. So from this 0, if I go a pi later, that'd be here. I got to do a full cycle, which means I must go up, back down through, and then 3 units down and back up. So it looks something like this. So there's what one period looks like. I'll keep that going. Okay, so basically it's just every one of these notches, something's changing. Okay, so this is definitely one of the more crazy ones. Oh, it doesn't even look like a... There we go. I want to make it look more like a sine. But you don't have to finish it. That's 2 periods there, but that's exactly what our answer is. Now the last guy here, maybe just for the sake of time, I'll fill this out. I'm not super concerned about you being able to graph something this crazy. I didn't do the mins and maxes here either. So this minimum is -7 because it from 4 down. So I go down 4 units and down 3 more units would be -7. If I go down 4 units, up 3 units, it's -1. So negative infinity to infinity, and then -7 to -1. Okay. Okay, so the last guy here. So again, I'll just fill this out for the sake of the video. So if I approve form, I want cosine by itself. So I just want this by itself. So I'm going to move everything else over. So y plus 1 divided by 1.5. And now I've got cosine. And I'm going to have to have a fraction here. So again, 2x plus pi over 4. To make both of those, I want this to be an x, so I'd have to cut it in half. So I'm going to cut both of those in half. So x plus pi over 8, but then put the 1/2 down here. Okay, because if I flip this over and multiply, I get that back. So it'd be x plus pi over 8 over 1/2. So my, let's see here, so phase shift would be left, pi over 8, vertically down 1. Amplitude is going to be 1.5. And then the period here, it's going to be half of what it was. It was 2 pi, now it's going to be pi. Okay, so if I go down 1, and then, so basically it's 1 plus or minus 1.5, that would put me at negative 2.5 up to 0.5. And then my range would be, oh, I did that backwards. Put that down here, and then from negative pi to pi. Write too fast. So this domain range, we'll do it that way. Okay. So this one, yeah, this one gets crazy to graph too, but for sake of time, I'm going to cut it off. This is really most important. There will be a couple times in the quiz I'll ask you to graph. I'll try not to make it too crazy. I don't want you to spend 10 minutes graphing one problem, but just for the sake of time, I'm going to cut that one off, just the graph part of it.